Oh, it's similar to the master set. By the way, on that master set question where you're trying to find the equations of motion for, that complex problem,
Yeah.
there's a video where I actually solved it. I don't know if any of you saw that video. Okay, at least two of you did. Let's see, what we care about is M sub R, so I only want the equations of motion for the wedge at the bottom. That is a right angle. The forces, I have F sub R. The acceleration is to the right. I have weight, W sub R. I have Y sub R. Y sub 2, F sub 2, and I think that's it. Did you want me to do the equations of motion for all of them, or just answer the question?
Just answer the question.
Yep. And this angle here is alpha. There are multiple answers for this, which is always a joy in grading. All right, so we need to first come up with a coordinate system. Any suggestions?
I had to the right and then J had up.
Okay. Any vectors we need to break up?
Yeah, like half of them.
Y2 F2.
Alan?
Y2 F2.
Yes. We just have to break these two up. And well, F2 is probably the simpler one to break up because it's coming down like this. I know that angle there is alpha. This is my F2. I'm going to break it up into horizontal and vertical components. What's the vertical component?
Sine.
Pardon?
Sine.
Yeah. So F2 sine of alpha. And this would be the other one, F2 cosine of alpha. So if I'm looking at that, I treat it like a point here. I've got F going to the right, big F. I have going to the left, FR. I have down, I have WR. Up, I've got Y sub R. Now with my friction, it is going down and to the right. So the downward one is F2 sine alpha. And to the right, F2 cosine alpha. And normal force is going down and to the left. Well, that's better. What are the trig functions that go with that? Well, it's perpendicular to F2. So the horizontal, I'm just going to change the trig function. So this would be Y2 sine of alpha, and this would be Y2 cosine of alpha.
Wait, I think, yeah, we understood that one. I mean, like, that's an easier version. On your test 2019, you have a force diagram that's like kind of similar to that one master set question, but I was confused on how to answer YP. Like there's some normal forces here that are so diagonal that I don't know how to do it. I was able to find weight, but I don't even know if I found it right, honestly. You just look at the, I found like the,
That's a fun one.
yeah.
All right, any questions about this one before we tackle one that's harder? right, so I've got an incline here. That angle there is alpha. I have a wedge. And I have a tension going up, not parallel to the ramp at an angle beta. I have Y2 there. I have weight acting down. I have Y sub P acting that way. And I have friction F1 going down the ramp. Oh, got a Y1 going this way. And I have F2. So F2, Y2, YP, all right. And then I also state that F2, or sorry, Y2 and FT are anti-parallel. Y2, FT, so Y2 is anti-parallel to FT, and Y1 and YP are anti-parallel. And anti-parallel just means 180 degrees between them. This was what, spring 2019, the mock test. Part of the mock test, I had a student who said that he'd much rather get his butt kicked before the test than on the test. And so when I made the mock tests, I didn't proofread as much. Some of you have some sense of how badly I proofread to begin with. And also the problems are potentially much harder than on the test. And, oh, the direction of acceleration, did I state?
Up the ramp.
Up the ramp. Okay. Now, there is more involved in this diagram, but this is the only one I really care about as far as the diagram is concerned.
That is true. Okay.
So, if it's moving up the ramp, did I say accelerating or just moving?
Moving up the ramp. It's accelerating and moving.
Okay, so acceleration up the ramp. All right, so coordinate system?
Hold on, I have a question about
Yep.
beta.
Yep.
What, cause
It's
mine has
important.
like a parallel line to alpha. That makes sense.
Yeah. I think that was just like an accident. This line that you see right here is a line that I created, but that's the actual horizontal line.
Ah, thank
That's
you.
my fault, sorry.
That's beta. Okay. Coordinate system?
Can we make it follow acceleration? Like I hat is the same thing as acceleration.
All right. And J hat,
Like, yeah.
that way. So, what do we need to break up?
We need to break up, wait.
I assume that was W-A-I-T, not W-E-I-G-H-T?
No, wait, as in like,
We have to break the weight up.
yeah.
Okay.
I think I did that one correctly, but I used a protractor, so that's the only.
All right, so we have to break that one up.
That one's fine.
What else do we need to break up?
With this coordinate system, is F2 or normal P like the same as J hat?
Y2 is perpendicular to the ramp and would be in the J hat direction. YP is anti-parallel to that, and so therefore it's in the negative J hat direction.
Which one?
YYP? Yeah.
So this is pointing in the negative J hat direction.
So then F2 and Y2 and FT all need to be broken.
Alright, now, those are the three tricky ones. Weight, I think we've done enough of that it's not gonna be as difficult as those. These, we need to be careful, but once we have one of them, the others should fall into place rather nicely.
Yay.
Alright, so let's take the simple one, weight.
Okay. So
MJ.
you cut a stroke.
Okay, that's the substitution, but what about breaking it up?
You cut it straight to where it'll have a 90-degree angle. At least that's what I did, and then. Okay, wait. So what I did was I put a line straight through the wedge, and then what did I do right after? I don't even remember.
I just know what still.
I don't remember what I did, but I know I did it right.
Alright, anyone else?
Can you remind me again what breaking up means other than substitution? Because I don't.
The decomposition, we're breaking it into perpendicular components so that one component is I hat, the other component is J hat.
Oh, okay.
If you had box on ramp,
Okay.
Then if the coordinate axes are like this, weight
Yep.
is like this, then isn't it a tangent function?
no, not a tangent unless you really want to get complicated. One of them's gonna be sine, the other one's gonna be cosine. Which one's down the ramp?
Sine.
Yeah. So I've got
Oh.
F1 going this way, I have W sine, I guess WR, sine of alpha. And then this way, WR cosine of alpha. R, what did we?
So I was right. It's a component of sine and cosine.
Yeah.
Which is tangent.
Oh my god.
Tangent's a ratio of the two. That seems like a complicated way of looking at it.
Okay.
But no, that one.
Wow, why did I find this
I called it, LW for large wedge. I didn't put a subscript next to the W. Okay.
So I was answering your
Let's see, Y1 is going this way, YP is going this way. Now we got P's to deal with. So I have to figure out how much of Ft is in the direction of the acceleration and how much is perpendicular to that. Or whichever one you want to break up. So the big question is, what is that small angle there? What is this angle right here?
We don't really need, beta prime.
Well, let's break it down a little bit better. So I know alpha is going in that direction. Sorry, that angle is alpha. This is going the way I've done it here, going up like that, so that angle there would be beta, that's Ft. Basically what I've done is I've taken this vector and I sort of shifted it to that point as opposed to the point of contact. So I have my ramp here, I've got my horizontal. I just moved the vector down to here to make it easier to break up. So that's beta, that's alpha. So that angle,
Is
Are
beta.
we working on FT?
pardon?
Are we working on FT? I got.
Yes,
Okay, sorry.
Beta minus alpha.
Wait, but
Yes.
like, I have a quick question.
okay.
How do you know that's alpha?
How do I know that's alpha?
No, how do you know that?
That's alpha?
Yeah.
I assume that the ramp is straight.
Okay.
Therefore,
The angle you make anywhere is gonna equal to alpha?
yeah, against the horizontal.
Okay, I understand.
So
Like any,
that's alpha,
that's alpha.
that's alpha, that's alpha.
Yes, 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 yes. Okay, I just want to make sure.
Wait, it's beta minus alpha, right?
Yeah.
Yeah, okay. Okay.
That's my head, so.
So when I break this up, the part that is going parallel to the ramp will be ft times the cosine of beta minus alpha. The part that's going perpendicular to it will be ft times the sine of beta minus alpha.
Okay.
Y2 is in the opposite direction. It is anti-parallel.